Hello everyone, and welcome back to yet another webinar session organized by Fogwing team. We do really appreciate and thank everyone for taking the time and joining us in this session. My name is Bobin. I am part of Fogwing's marketing team. I'll just give you a quick brief on today's topic. Today's topic will be based on machine monitoring, modern way to optimize productivity. We'll be going through the modern techniques for machine monitoring, digital transformation, and machine productivity monitoring, the smart fogging metric solutions, then real world case studies, and some success stories. That will be a brief on today's topic. And for those who have been part of a previous webinar, we are glad to have you back here. And for those who are joining us for the first time, let me take a moment to provide a brief introduction about us. Okay, we are Fogwing. Fogwing is a leading provider of industrial software solutions for Industry 4.0 or industrial transformation. Fogwing is an industrial cloud which offers a wide range of digital transformation solutions, especially tailored for manufacturing companies by leveraging IoT and AI technologies. And let me give you a quick note on Fogwing's product offerings. So, starting with the Fogwing IIoT platform, it's a platform which enables seamless connectivity with machines and assets, helps in facilitating efficient data aggregation. Then comes the Fogwing Asset Plus Smart CMMS. It's a comprehensive maintenance management software provided by powered by like IoT and AI technologies, designed mainly for asset reliability and maintenance operations. Then comes the Fogwing Matrix. It's a production monitoring solution for effortless machine monitoring, downtime tracking, OE optimization, etc. And today we will be having a demo of this Fogwing Metrics application. And next comes the Fogwing Vision, which is a smart quality check solutions for automated quality scanning of finished goods using computer vision and machine learning techniques. And also we offer Fogwing Eco, which is an air pollution monitoring solution, which includes both hardware devices and software. It's mainly for industrial pollution monitoring. And also we have been like assisting numerous medium and large enterprises in their journey towards adopting industry 4.0 and digitizing their manufacturing operations. With the global presence, we operate in India, US, Europe, and also rest of the world through our partner network. So today, Mr. Hariharan Ganesh, who is the founder and chief architect of Fogwing, will be presenting this webinar. Before getting started, a quick note, if you have any questions, please do not hesitate to ask. You can always shoot your questions in the chat box. All your questions will be answered, towards the end of the webinar in the Q&A session. And also, a recorded session of this webinar will be available on our YouTube channel soon. And for those people who are watching the recorded session of this webinar, you can post your queries in the comment section. We will be answering them all. So that's it. So without further delay, let me hand over to Mr. Hari. Hari, over to you.
Thank you, Bobin. Hello, everyone. Good morning, good evening, good afternoon, wherever you are connected and watching this video at a later point. So today, we would like to talk about how do we optimize the productivity in manufacturing setup or any machine operational business model. I wanted to start with some quotes from the Gartner reports. So when we talk about optimizing productivity, which means that we are looking at how we can improve the production operations by reducing unwanted effort or time waste or any other wastages. So when coming to the wastage, how we can reduce the wastage means any effort wastage, and how we can improve our efficiency of productivity. Then obviously the immediate practice is called a Six Sigma lean manufacturing process, and Gartner recommending it's a best way to identify the manufacturing wastage, I mean the efficiency wastage, and improve the process by various steps and actions. So um, so we are going to talk about productivity and how production monitoring is going to happen. Before going to production monitoring, I want to set the understanding clearly on what are the different way we are losing the efficiency of our manufacturing process. As again, 8 ways of lean manufacturing process, which also called as team words, identified the 8 areas where potentially every manufacturers or any industrial operations company can lose the efficiency. So that includes starts with teams in terms of team words in terms of transportation, by moving things, unplanned moving things, inventory, over inventory of raw materials, which also considered as waste because it's basically not required to procure immediately and then getting things done, especially chemical storage. If we are a manufacturer of product using chemical materials and you cannot store it in a longer period, and procuring and managing inventory is crucial for the timely production as well as defectless production output. So inventory is crucial. Motion of things, like moving things on the need basis, like when the machine is running, if you're trying to move, then obviously the motion takes time to manually moving things. At the same time, there is a machine is also in the waiting. So that's on the third and fourth option, like fourth way of losing efficiency. And overproduction, in terms of unplanned production or overproduction, which required, it create more number of items even though it's not required. And again, it goes back to the inventory of finished goods and timeline to store and the capacity management, all stuff. The last three are more relevant to over processing, adding more and more process steps into the production process, which takes more time to complete the product, more time to get the finished goods output, and that might be resulting in defective items, that might be more and more defective items being produced because of overproduction or over processing efforts. The last one is the skill loss, because of moving workforce, how much the knowledge that built, how we are managing knowledge and how we can share the knowledge between the how we can maintain the overall production process and steps and procedures more efficiently, and that level of knowledge loss. And all of them are predominant 8 ways of lean manufacturing. But since we are going to talk very specific to production monitoring and productivity improvement and using from the machine monitoring aspect of that as part of this webinar context, we can consider there are 5 items we identified as a potential area where it involves in and around the machines: the motion, the delay in getting the raw material to the machines and loading into the machines, the waiting time for the machine when the material is available, when not available. So the machine is not running, it's basically running, but it's not producing any output. Overproduction in terms of unplanned efficiencies, sudden increase in cycle time, which results in over quantity produced within the timeline, that might lead into a defective item as well. And then over processing, in terms of the number of steps that we are following in the overall execution of raw material to the finished products. What are the steps we are following and how efficiently these machines are coordinated to work together, and all of them. So these are all 5 areas that we would address by just monitoring the machine, because it's all in and around machines and its performance, probably in operators' performance as well. So in terms of productivity improvement, we need to focus on these 5 areas, which could result in 100% efficiency increase as per our studies. So let's take understand it. Generally, this machine monitoring is a very generalized word. It could be leading to any different aspect of manufacturing operations. We have identified this as 3 key areas of observability, because at the end of the day, monitoring is all about understanding how things are happening and how we can improve it, identify the gaps, how we can improve those gaps with efficiency. So the first one is condition monitoring. So mission and its health condition are critical for efficient productivity. So the condition of the mission is very, very important. So monitoring the condition of the mission in terms of the mission operational timeline and temperature, maybe vibration, maybe other conditions, the mission health conditions, the mission that goes through at the time of production and offline time. So how do we monitor it and make sure we have the mission that are available for immediate productivity, and that's not stopping any production actions. So the mission availability is required, very, very important, by through condition monitoring. That's one type of monitoring in mission monitoring subcategory. Second type is on production monitoring, which predominantly focusing on the mission outputs like a cycle time, quality of quantity produced and quality of product produced out of the mission, and what is the waiting time, what is the loading time, when is unplanned time, how much is unplanned time down, unplanned down, and how much is planned down. So all of them is considered as part of the production monitoring because it's more about data that's the productivity as output of that. The last one is on the maintenance planning. So again, it's based on production as well as the health data together, because how much we are producing, how long we are producing is important, and also the mission health conditions. The both data together identifying the maintenance frequency. So either we do preventive maintenance or we do predictive maintenance. Either case, the mission health condition as well as the productivity information is important to consolidate together and have a complete visibility in terms of the maintenance activity. Again, unplanned maintenance will also impact the productivity. So there are three type of production monitoring, which is more into condition level, productivity level, and maintenance aspect of that. So all three of them are important to have a holistic view of the asset. And that helps us to understand how all combine together and acting in our shop floor, and then identifying the way of improving efficiency, productivity, even in the maintenance planning and executions. So when you say mission monitoring, that could lead into any one of the area or all combined together. So today we are going to talk more about the production monitoring and productivity aspect of that, as well as some level of conditions monitoring. We will be, we have a webinar next week where we will be talking more on the maintenance aspect of that. Using the same context, we will be talking on the maintenance aspect. That should be the next week webinar. So let's go into the modern techniques, because I wanted to show a demo on how we will do it in practical. Before that, I wanted to quickly catch up on the context and concept, how we are doing it. So the modern techniques. So when you say modern, that should be something else, right? So that should be what is traditional, what is something happening today, and what is that modern approaches. So traditionally, as far as our exploration, when we spoke to many manufacturers, and we observed it, there are three type of traditional practice in place. One is based on the paper-based. There is a tracking sheet provided by every operators, and they just tracking it, how long they are running. Every hourly basis, they are writing it in a writing pad on the productivity and when they started the machine, when they stopped the machine, when they are how much in each and every hour they have produced, what product they have produced. They're manually writing it. These paper sheets are sent to the common IT team or MAS team, and they convert them or manually inputting them into the data sheets or Excel sheets, and then they're processing it to create a reports. That report sent to the management for reviews. Obviously, that takes year to month to get the reports from the shop floor in this traditional approach. The second approach is, having a machines, CNC, PLC machines. There might be a inbuilt storage, but they are not connected machines. So obviously, the data, the productivity information or the machine operational data gets stored in the form of logs. So typically, some of the manufacturers, they have a way to go to the machine, connect to the machine through laptop, and then they import the data to the laptop. Obviously, this comes in CSV file or Excel file, and then they try to manually merge these files and then come out with, and then applying the calculations to identify the OEE metrics or performance metrics or even, productivity informations. So this is the second type of things. It's a little more improvement than the paper-based, but still it's involved the manual effort to do that. Suppose the engineer is not available on the day, they may not collect the data on the day. So they may go for next day to do the outline. So there is a delayed timeline. There is a manual effort to merging. There is a possibility of human, human intervention. Because of that, there is a possibility of data loss. So all of them leads into, again, time delayed report to management. The last one is on the SCADA systems. Some of the manufacturers who connected these machines and they collected all the data into the SCADA system, which is a common data repository or database system. And then they write a program scripts to convert this into a metrics, and any data loss, only they will arrive up at the time of report generation. Again, it's a little more improvement compared to the paper and downloading manually, but still it's a manual approach and lack of visibility into the more accurate data. And also there is a possibility of corrupted data that leads into inaccuracy in the reports, the OE reports or performance report or any productivity report. So this is what we have seen as a traditional approach. But what we are going to look at, what we are offering, as well as what we are going to look at as a modern approach as part of the Industry 4.0 or technology solutions. So we will be leveraging the IoT technology to real-time capturing the data from the machines. We will see how we will capture it in the subsequent slides. So we will connect the machines and collect the data real time from the machines without any human intervention using IoT devices or IoT connectivity. So then aggregate the data in some places and then, then process the data. So then processing the data requires, automated data cleaning, analytical extractions. So that is an automated build process that, do the data extraction, identifying the key identifiers, and then started, consolidating together, aggregate together to come up with the metrics like OE metrics or downtime metrics or, top downtime reasons and things like that. So those set of data sets are going and stored in a system, and then further it is provided visualization to the concerned audience, the stakeholders, the plant managers. So so in this approach, we could do the data gathering at real time, we could process the data at real time, and we could also present the data at the real time without any human intervention or limited level of human intervention. So we could do all of them together, and then the data access is immediately available to the management or top management or even the plant management team to instantly understand what is happening in my factory, which machines are down, which machines are up, and how the cycle time, how the productivity, what is my schedule loss, and things like that. So this helps them to understand the overall efficiency of production process to come up with the gap identification and then taking actions into that. At the end of the day, the action has to happen after monitoring, but this is a way that easily they can understand. No need to wait for a week or month long to understand the actual production. So the modern way is to using technology like IoT, big data processing, AI, and things like that too, and then mobile and modern web technologies to use those technologies to give the monitoring solution at real time. So how this will happen, right? So what is it? How do we do that? So there are steps as I explained. Number one is the connecting to the machines. So and then the question is, we have a PLC based machine, we have a modern machines, or most of them, they have a 5 years old, 10 years old, or 20 years old machines, which are not highly equipped machines to read the data itself. Some of them like a manual machines, which do not have any control unit, a manually operator, lifting and, drilling and things like that. So those kind of machines. So we identify as a 3 category of machines altogether, even though either is a PLC based machine, Siemens systems, or Toshiba systems, or any other regional level machineries. So we have identified as 3 categories of them. One of them is the digital output systems, which basically having some kind of a digital controller or a controlling unit, and where there is a signals going, electrical signals or digital signals are going. We could read those signals from the machine itself using the ports or the mechanism available by connecting to the control units. That's a one type of data gathering or data reading from the machines. Second type of them are PLCs, which are programmatically controlled and that already have the program that have the data sets stored. We could read that through PLC interfaces like and OPC UA or any Modbus interfaces to read the data from it, and then convert that data sending to that. Third type is manual machines, which are not having any electrical controller. There is no PLC program or anything digital controlling in it. So it's all manually operated machines. They move things up and down. So in those cases, we need to put a retrofit sensors at some points to read the output of them. So this kind of a manual reading, like a conveyor belts, what is moving on the belt, on top of the belt is invisible to the conveyor belt. So basically, we need to put a sensors to read the data from the conveyor belt to understand, what is the moving parts and how many parts moved and things like that. So that's a sensor based reading. So any three type of machines, any one of the approach that we could follow to read the data. As soon as we read the data, we send it to the data aggregation environment, which predominantly a data storage. So where it is get first stored all the data. Then once it's stored the data, then we run the process, the data processing, which basically taking the data, clean the data. Sometimes machine data are coming in analog signals. The outputs are not in a numerical format or in the numerical format or alphanumerical format, and we need to convert that into the meaningful information. It may be array data, and we need to read a particular value at the particular positions to understand what kind of information is gathered on that. So doing all of them and then identifying the key information like OE metrics, to understand availability percentage, understand productivity percentage, understand the quality percentage, and then arriving the OE output on that. So by doing this data gathering together and then processing it, we could extract the different type of metrics. We'll see that what are the different type of metrics we can gather on that. And then going into the storing these metrics into the analytical platform or a storage repository where all these metrics are stored, not the actual data, the real metrics are stored. Those metrics can be presented in the UI format to the operational team for real-time visibility and things like that. So this is how the step-by-step we approach in a way. But everything, building this solution takes time from scratch. The beauty of what we are solving here is to get this all of them make it ready at the turnkey basis, so that the solution is ready and we could do and quickly we can help the customer to start adapting this technology faster. So why machine monitoring is important? Again, I just wanted to put some of the key points, why it is very important for productivity, improving operational efficiency. Understanding, very number one thing is to understand how things are happening. So there are key 8 benefits that by doing real-time monitoring, we can do gain 8 different benefits. Number one, understanding the asset utilization and its effectiveness. So, and then identifying the way to improve it in that. Optimizing the efficiency in terms of how we are planning and executing the production operations, how we can plan and execute when the machines are overutilized or underutilized, and based on that, and then reducing the downtime by monitoring the machine usage and the timeline it is being used and its efficiency of productivity by taking and considering all of them, understand the health and then improve their downtime. Could be a stop reason, could be a planned downtime, unplanned downtime. All cases, we should reduce that downtime by understanding how things are happening and then how we can improve it. And then improve the quality of things, by considering, process parameters and understanding the process, when I say process parameter, the machine processes, and in terms of the feed level, the material, material conditions, raw material conditions, and then the output conditions, understanding all of them, we can improve the quality of the material output from the machineries. By educating the operators and making it, reducing the operator manual entries, manual effort, or manually they are going and writing it. So increase the efficiency instead of writing in the papers, if they are getting this data processed, and then they can focus on the production instead of writing in papers and tracking things and all. So the improvement in productivity happens by workforce improvement. Helping all this data together, understanding, what is really happening and taking a better decision. Also, it helps to reduce the operational expenditures, in terms of inefficiency expenses. Finally, helps to understand what really happening in the production for the maintenance team. Oh, okay, this is how they are using machine. This is the machine output. This is how machine is operating. And okay, this machine is running. How long this machine is running? Okay, how do I improve these machines? How do I do my maintenance planning activity? So helping the maintenance team to understand the machine usage and running period, and then they can take a decision in terms of planning and executing the maintenance operations. So all of the key outputs that we could expect out of real-time machine monitoring activities. Now comes into the picture, we are, as I said, as we looked at before, we are a Industry 4.0 solution provider, and we have a platform built to increase the productivity efficiency. So we have we call it as a matrix application. And this application, this platform itself, it's built with the IoT and AI technologies, with inbuilt, with coming with the required hardware, components to connect to the machine and read it. The biggest challenge in machine monitoring or productivity monitoring or production monitoring is how do we connect to the machine? How do we get the data out? And we have solved this by using three basic principles. One is through IoT connectivity, reading analog digital data or PLC systems, and then using sensors, using the current sensors, the proximity sensors, and things like that. Also, in cases the machine cannot say, why I'm stopped, I have some problem, or the machine has been stopped by the operator due to something the operator seeing, something weird is happening on the machine. So they stopped it. So that cases, operators' visibility and input is very, very important. This is not a manual entry. It's more like getting opinion from the operator. So in that cases, we request operators to give their input. But how do they do that? So they need a HMI kind of interface. So we also build the HMI interfaces. So this is the first platform which provides both HMI and IoT-based machine connectivity capability, along with the application systems together as a single platform, to apply to any manufacturing setup, and then start leveraging this technology and start monitoring the production aspect. This whole platform or solution provides three primary area of focus. One is machine performance monitoring, of course, tracking on the OEE, downtime, uptime, productivity, efficiency, utilizations, all key metrics parameters, first time right, the yield, all these key parameters we could monitor it using this technology. Second level, process monitoring, which is critical for process-oriented manufacturing setup, where the machine and the raw material supply, machine condition that machine is running, and the material, flow of the material, feed of the material, the level of material conditions, all are important to understand the quality output of that. So why my quality is poor? To understand that, we need to measure the process parameters. Typically, again, this is all manually monitored by sheets. So they usually write it the temperature running, and then they usually write it the flow level, the feed level, the output level, and things like that. They will manually writing it, the process parameters as well. But we can use a sensor technology, or even inbuilt, the machine already have a capability to reading it, and it's displaying in something in the machine level itself. And we can capture those data using our technology, and then we can consolidate the process parameters, process trends. And then last one is the downtime trends. Very important to understand why we are stopping, how frequently we are stopping, what is the reason for us to stop the machine. Either it's a machine fault or it's a machine is stopped by operator. So understanding that trend help us to reduce the wastage time, which is basically the waiting time, or maybe the machine conditions because of that, the maintenance conditions because of that we are stopping it, and those kind of wastages that we have seen before. Those kind of wastages can be identified and reduced. So our platform provide all three aspects, which gives a kind of 180-degree view of the machine, except the maintenance. Maintenance we are seeing in other application that we will see it in next week. Okay, so how we do that, right? So how our systems work together. The same principles as I explained, how the machine monitoring should happen traditionally, or in the modern way. The same way we are also applying our technology. So we connect to the machines using our edge devices, IoT edge devices. These devices are IoT-based devices capable of capturing, connecting to any missions, pulling the data out, and then storing that locally in case of any connectivity issues. It can work in offline mode, so you don't need to stop the production, you don't need to lose the data. It works in offline mode, online mode, so it can capture the data, store it locally, and then sending the data to the cloud. Suppose if it is a mission that we read it, mission has a capability, and it has a data sets inside that, like there is a modbus or CAN bus or Profinet interface available in the machine level, and we could read the data directly from the machines, like a cycle time, and then the product in production, or maybe the quantity produced. So we could read all this data from the machine directly from the PLC machines, or other interfaces, and then send the data directly without the human intervention. So that is possible, 100% possible, if the machine already have all the data sets, including the machine fault conditions. If every data is there, we could directly capture the data and send it to the cloud for processing it, and send it to the data aggregation level for processing it. Whereas, if it is a machine is giving only a output cycle time, or it's only giving a production count production, but it's not giving what product is making, or it's not giving what why the machine is stopped, why the machine has been halted, whether machine is waiting for material or not. It doesn't give those kind of information. It's only giving a limited information. Then obviously operator input also required, but they can do the input at only one time for the entire period, and we capture it one time inputs. They don't need to write it every hours. They don't need to put it in every minutes. They can just give that, I'm producing this product. As soon as they start the production, they can just say that, okay, I'm starting this production. I'm starting this mission for making this particular product. And then they can start feeding that information, and then the entire period cycle time, and the entire period of that, the machine will consider that product is being produced, and then it's feeding the data to that. The other way is, if it's a manually we are reading it, like sensors, we put a sensors, we read it from IO, we convert this IO data like a digital frequency or analog or current frequency, and the intermediate frequency of currents. So we read that and convert that into more of meaningful data, more of a cycle time. We do the calculations on the device level, and then we send the data to the operators as well for any input, and then sending that data to the aggregation platform. So we have a Fogwing IoT, which is a data aggregation platform, connecting to the machine, managing device management, getting the data, and showing it in the storing it in the process. Once the data get aggregated and that data feed into our matrix, which is more like a manufacturing production analytics platform. This is more like built with the analytics capability, and read this data and processing this data to come up with the metrics, the production metrics such as OEE metrics or OOE metrics, first time right, quality metrics, and all. It calculate all the metrics and storing these metrics internally, and those metrics are presented to that in the system with the web interfaces through the production dashboards. So these dashboards are real-time dashboards that takes the data. The entire data flow happens in real time through our IoT and data analytics platform combined together to deliver the output. This is how we implement the solution and we operate, and our systems are pre-built with it. So all we have to do that is, any customer comes to us and they wants to connect to their machine to monitor it. We understand what is the mission type and what kind of output is coming. And then we pre-program our devices and HMI. We ship it to the customer, and customer can just simply follow our video instructions, and they can just plug into the machines, and then they can start connecting the data, and the data comes into the cloud. So if there is any data conflict on that, we address it in the cloud, and we remotely update the firmware or system level to make sure everything is calculated properly, and then the data sets going into there. So within 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 a short span of time, like a weeks, we could make this fully operating and fully efficient output is coming into the system, rather than waiting and building the entire process from the scratch. So we highly recommend our customers to leverage this technology, which is already made for them. So still the question is, how do we connect it? What kind of these devices, how these devices are connecting to there. So there are two devices we looked at. One is the edge device, which is an IoT device, and then we have a HMI device. The edge device is capable of capturing the data. It could connect to the machine, can start reading the data. If the machine provides the data, like in the OPC UA, Modbus, CAN bus, Profinet, we could read the data, or the data coming in the IO platform, like GPIO or 232 or 485 ports. We could also read it from there, or the sensors, using sensors. We can also build a localized server, on-premise server, to combine all the digital data and send it to the cloud. This platform supports Wi-Fi, 4G network, and depends on the environment where the device is deployed, and we could connect to the cloud and then sending the data. On the other side, the HMI is capable of coming with the inbuilt application, the HMI application for mission matrix purpose, and start capturing the information, validating with the operators, questioning operators, why the machine is stopped, and asking operators to answer it, why you stopped the mission, can you give me the reason for that, and capture those reasons and send it to the cloud. So instant sending alert and all. It's a touchscreen based, ultra wide touchscreen based model with inbuilt 4G. It can also connect to the machine and then getting the data out in case IoT is not required, and the single device can also do the both role, IoT as well as edge and HMI capabilities. That's a uniqueness on that. So the hardware devices that we support provide are ready to connect, inbuilt firmware, edge firmware, inbuilt HMI applications, machine connectivity, in any machine type of connectivity, wireless communication options are there. And then most important thing is it works in online and offline mode. So there is no need of, there is no point of connectivity issues or anything, or data loss, and because these can capture every data and send it to the cloud. Okay, so let's go and see that. The features includes plenty of things. Instead of talking about here, I would like to show it in the application, and then we can come back here and look at what are the things we have seen here. So let me get out of this presentation and go to the application. So I'm going to show the cloud application first. So this is our cloud interface. Right now I have logged in as a plant manager, plant level manager access. And in this access, let me refresh it. So just to get the latest data. Yeah. So this is a dashboard. This is a pre-configured dashboard. So as soon as the plant manager, as soon as we set the system on board, the plant manager will start seeing these data sets. They can log in and see anytime. And also, this can also be used by other supervisors and other people as well to monitor it and at the different scale. So the dashboard level, we give 4 key parameters at the overall plant. This is the overall plant, including all machines running within the plant. Overall plant operational metrics. It's not just one particular machine; it's overall plant operational metrics. So the OOE is coming into the overall plant level. How the overall efficiency is, the throughput of overall production throughput. The utilization of the machines in the overall period, and all the machines, all the assets, how being utilized across the organization, and then the quality of output, the first time right quality output, and how much productivity is happening in terms of percentage as well as the count level. Depends on that. Sometimes the count may be vary from product to product, but efficiency percentage will also indicating the level of efficiency in quality. Then what is in production? How is the production happening, right? So overall plant level. So it's an average value of all assets. So OEE, overall equipment efficiency across all assets, availability of based on all assets, performance of all assets, and quality of all assets. It's an overall consolidated overall production across plant. Then comes to the who is doing better, means, which shift is operating efficiently. So it's based on shift. So you can configure a number of shifts in the system, and you can see that, how efficiently my shift. So right now I'm running in the first shift, which is a morning shift, started at 6 a.m. So in this shift, so far is 308 minutes of shift production. And I could see that, there is a 4 minutes of downtime on this. So there is a downtime. It's not a planned downtime. It's not an unplanned downtime. Looks like, some operator is not entering or not giving the data on why they stopped it. So there is a unknown reason it stopped it. So I need to ask the operator why you stopped it. So this is the way we capture and indicating it, in the operator's efficiency also, whether they are really doing in the conscious sense of stopping the machine and for purpose. So there's a 4 minutes of downtime so far in this mission. And then, in the other side, based on the production, based on the schedule, how much it is lost, based on schedule, it's a 4 minute stop. So I think, based on the efficiency, 4 minutes is down. So basically cycle time is going on more or less same time. That's why if the cycle time is very slow, then obviously the production loss will be high. You can also see that 7 days data. You can see that, previous day there was a downtime. You can also see the 30 days data together. So here itself, you can see the overall efficiency across organization. And then overall plant level, what is the top 5 reasons the downtime is happening? So that's called troublemakers. We call this troublemakers. So means what is the reasons for downtime? So top 5, based on all missions, all metrics, what is the overall downtime? So number one is top reasons is a planned reasons, which is loading, braking. So loading takes more time. As far as last 30 days, 40 minutes has been lost because of the loading time. So this is a potential area to look around, and how do we plan and bring the materials on time near to the mission, so that, the missions can continuously run while feeding. So we could identify that. Or the break time is a 16 minutes. Sometimes it may be over, and we need to think, any scheduling changes we need to do that to make it efficiently. The fault reason is also very important. Why mission is stopped. Suddenly mission stopped because of fault reasons. So 169 minutes of the last 30 days, we lost more than 169 minutes of power drops, basically because of some sudden power breakage, which causing a significant amount of hours, minutes of time, hours of time in stoppage. This must be improved. We need to look at why the power is dropping more frequently. Overheating is another issue that sees 127%. So this is how it indicates why overall my operations. And then also it gives what is in production. So as of now, what is my production? Each and every missions, what is happening in the production. So it gives all the data within single things, in the dashboard, where you can see what is happening production, how my efficiently we are producing it, what is my loss, what are the issues that happening there, and what is the overall production happening at all mission level. So now I want to go drill down into each individual mission level. So as of now, I have this in this account, I have one mission configured. We can add in number of assets to monitor. So in this one, it is going at the drilling down into individual level. So today, I have around, this is the overall production in this mission. This is the mission running time, 99% utilization. This overall mission is, and then this is what is production happening. There is some unknown also. Expected cycle time for this particular product is 35 numbers per seconds. Actual cycle time is also 35, more or less equal, and then overall output is coming like that. So again, I can see the performance of this particular mission individually, availability, performance, quality. I can also see the trend of the performance in terms of availability. There was a loss in initial period at 6 a.m. So it was 94%, and then it's going into 100%. Maybe some preparation loss. That's what loading time loss. And then there is a performance also. It is going more or less 100%, but there is a dip in the at point 99%. There is a quality also. I think quality is going 100% because we don't have any negatives here. Out of 313 minutes running today in the current shift, 4 minutes is lost, which is we don't know that. We need to ask that why they have made it. So suppose this is the correct one, and this shows the accuracy of the data itself, how efficiently this data is being calculated. Suppose I want to see yesterday's performance of this mission. I can go here. I can see yesterday's performance. Yesterday overall production is this, and availability is the overall performance of yesterday from this mission. And then the availability went down yesterday at 65% at point, and we need to know why it is. The number of mission downtime reasons, top 5 downtime reasons, and the loading was one of the biggest issue yesterday for the availability loss, and also the productivity. Whereas you can also see the process. So yesterday overall process, the temperature maintained in the system was on average yesterday it was 392 degree Fahrenheit. And I can click that and then see that how much, what is the efficiency of that, is it continuously maintained on that level, or is there a dip? And I could see that there is a dip on the midnight, where it was temperature was significantly reduced and then recovered from there. So there may be a potential quality issue during this time that should be recorded, and it is not recorded. So I need to ask the supervisor why this machine is, the temperature is down. Obviously, the material may not be in the right temperature. Then how come there is no quality issues? So we need to question them and get a clarity on that. So similarly, you can also monitor every every parameter on this. 1 second. So every parameter on this, and then I can go to the speed, and then I can say in the same way I can see the speed of that. Yesterday same time there was a speed reduction and things like that. So this is how we take a measurement on the system, and then we can monitor it. And also you can also go to the metrics, and you can see the performance metrics of this particular system, last 7 days of performance metrics. Based on OE, how efficiently my machine is running, and overall metrics, and these reports can be downloadable and things like that. So that's a quick demo on how do we configure. There are a lot of configuration here in terms of your plant performance, downtime reasons. In fact, you can configure your downtime reasons and ask the operators to scan the barcode and then feed the data into that. So this way, you can capture this downtime from the HMI itself, or if the person forgot to update it, and the operator did not provide the reason for downtime. So I could see this, this could be an issue. So I'm going here, let's take today or yesterday or some data sets. Okay, I see that there is unknown reason. There is a loss. So I make it as an overheat. I updated it. Supervisor can do this work. So now if I'm coming back to the machines, and it will say that what is the downtime reason. So you can see here it is already coming here as overheating. The 4 minutes has blocked it as overheating. So even if the operator is not doing it, the supervisor could update in the system for better accuracy. Instantly it get updated, instantly it activated in the system, and the metrics are more accurate. So there is no manual, there is no manually merging data, or taking copying pasting data from one Excel to another Excel or any other systems. It's all happening on the real time on the systems, and it is visible to the management. Coming back to the application. So as we saw, we have a so it's a plug and play machine monitoring capacity. So we can ship the devices and can be just plug into the machine. We help them through video calls and remote calls. We help them to configure it. We guide the maintenance engineer or the engineer mission engineers to fix the equipment that we are shipping. We also have a YouTube videos on how to do certain missions and all. How do we look at the device? So we also have the YouTube videos to share it. Our devices are network agnostic. It can connect to any industrial protocol and read that data. We will pre-configure it, we ship it. So there is no manually somebody has to develop or anything like that. We have operator inputs, HMI applications. Getting the operator's input, very, very important. Operator input is important, but at the same time, we need to instruct the operator on what they should do that, and we don't need continuous data from them. Just a one time they feed the data, that is enough for us to calculate the rest of things. We are improving this model with the ML machine learning approach in the modern AI technology. To automatically identify based on the trend, based on the mission identification. We are working on improving it. So the OE metrics is coming, OE metrics is coming, downtime versus runtime. We can see that planned versus schedule loss. We saw that performance trend in terms of process performance, efficiency metrics. I showed it on that. And also we have a standard reports. You can easily export the report and things like that. We have if you're interested to see more detailed view of this demo on this application, you can reach us, our team, and we will schedule a separate call where we will walk you through the HMI level as well as the application level on how do we do end-to-end of that. Okay, so the case. So we have tested this platform with multiple manufacturers, from the small scale and industries to the large enterprises. So one of the case study that we wanted to discuss here is one of the customer who, again, same problem. The biggest challenge for them is in lack of transparency. They don't know what's happening, how efficiently they are operating. They just operate on a day-to-day basis, and some of them, the schedule is slipping into next day, and they are getting more orders, but they are not sure whether they have to buy more machines, or is there a way they can improve the existing machine performance to get output. So they were not sure what is the challenge, or what is the issue on that, on improving, whether they have to, is there a possibility to improve or not. So there is a lack of visibility from the customer standpoint, and they were tracking everything manually, using papers, and some systems are using SCADA, but they are not getting all together in one single platform. So they are getting in a different reports at different time. So the holistic view of the asset is not, the holistic view of the overall plant level performance is not visible to with the plant manager as well as the operational team. So they wanted to have kind of a monitoring solutions. So we basically, the way that we approached in the solution is, we requested them to give the machine information. We studied the machines, and then we configured our hardware devices. We ship the devices to them. We help them to connect to the machines. Some of the machines are equipped with the VFT controller. Some of them are, analog sensors that we connected with through our current sensors to detect the machine running time. And also some of them are, captured through the HMI inputs. So we shipped to them, and they connected, they started capturing. We fine-tuned the data sets to make sure everything accurately coming. Sometimes, incorrect configuration might lead into incorrect data. So we fine-tune it through our data science team, data processing team to understand how efficiently the calculations coming. We cross-check with that. And then we have given access to the customer to start leveraging the applications. So that leads into a lot of visibility for them. So number one, they had a lot of downtimes, unknown downtimes, and they started enforcing the operators to give the reasons, and they captured why they are stopping unnecessarily, and what is a different frequency of stop, and that leads into downtime, visibility in the downtime, and they took a step to give a clear instruction planning, and that reduced the 60% of the downtime has been reduced. Another one is waiting time. So a lot of time, the operators are waiting for materials, and that's lead into machine is running, it's consuming energy, but it is not making any output, and that's a big issue. Because they're both side, financial loss as well as the waiting time efficiency loss. So they captured that also, the reason for waiting period, and then they have planned the production schedule accordingly to reduce the waiting time. And in terms of the movement of the materials, like transportation of the raw materials to the machines and things like that. So they improved their process, and through which they have reduced the waiting time. And then management is very happy because they had a very high visibility in terms of the operations. There is still some improvement, the people process improvement, but they had a very, very high visibility. Previously, they were waiting for weeks to get the data and then see that, and they were not trustworthy data sets, which are manually entered by everyone in a different timeline. So they got a high visibility. The overall OE itself increased 15% on the overall improvement compared to previous efficiency, and that's lead into more production using the same assets. Instead of buying new assets, they could increase that, distribute that 15% into each machines. so they could increase, reduce the new purchases and then, improve the efficiency of the existing machines, leveraging the technology, leveraging the machines, efficiency to made production, high productions. That's how they have solved this problem within the duration of 3 months. They could see a significantly 90% overall operational efficiency improvement. Okay, so quick note and what is going to come. This is exciting because we are adding more and more features. We are adding more custom standard reports and custom reports for the operational team to extract the data. We are going to launch a mobile app for quick monitoring, getting alerts when the machine is down. We also working on the visual shop floor monitoring, means using camera devices to monitor the machine, and then tower lights monitoring to identify which machines are stopping, and coordinating the visual numbers versus the actual machine numbers to match whether visually it is correct or not. Sometimes there may be a gap in when the machine stopped and the operator reporting. So identifying that, we are bringing that to address the gap. We are bringing the visual shop floor monitoring using our camera devices. We are improving the HMI devices available in the tablet versions. We also building a integration with the SAP and Microsoft Dynamics. So all these data feeds can help to connect to the data and send it to the SAP system for planning and execution standpoint. So we are working on all this technology. This all will be available in the next year on a frequency in a periodic basis. We are launching one by one and working on to improve the overall system. That's it. Key. I think you would have seen this before. We have three primary product suites from the smart operation, smart maintenance, and smart quality solutions. That's it. I think back to you. I think there are some questions, I believe, and we can probably answer it.
Yeah, thank you, Hari, for the deep insights. We do have a few questions. I'll just read it out so you can respond to them. So the first question: do you need Fogwing IoT platform previously installed or only Fogwing metrics?
Okay, good question. So Fogwing IoT is coming along with the Fogwing metrics. You don't need to, it's bundled together. So you don't need to have a Fogwing IoT first and then do the metrics. When you purchase or when you procure our metrics application, the matrix application comes with along with IoT. So we can collect the data on the fly and then send it to that. So you don't need to buy, you don't need to configure and buying anything, implementing anything as IoT first. It comes inbuilt with that.
Okay, on to the next question. How user-friendly is smart fogging metric solution, and how quickly it can be implemented in a existing manufacturing setup?
So existing manufacturing setup, it's again, based on the mission. Number one that we would consider, we wanted to evaluate is the type of missions and condition of the missions, whether these are all modern missions or, legacy missions, manually, operating or digital airport. So we need to know that. So that's a very important thing to understand the timeline and the size of the organization, obviously. But we also do the incremental implementation approach. Typically, the timeline for implementation varies from 2 weeks period to 4 weeks period or 8 weeks period, depends on the size of the organization and the condition of the missions. Second thing, the interfaces are very user friendly. You would have seen that in the demo. They are very user friendly. They are very accurate, realistically accessible. We also getting feedback from the users, from the operators, from the HMI system, from the operational team, and improving our user experience level in the application for more useful and understanding and giving richness to them, more insightful information. So there is a lot of scope for taking this solution and improving the efficiency. Also, we are also working, as we see the roadmap. We are also working in adding more and more features to understand, to add more capabilities to address the gaps in terms of data capturing, or visually how we can compare the visual of the factory operation versus the data feed from the machines and the operators. Combined together, how do we understand the holistically and all? So so everything can be done. The timeline, again, to answer your question directly, timeline varies from based on number of size and machines and type. It takes maybe a 2 weeks period to 6 or 8 weeks period, depends on the type of machines and the complexity in the data capturing.
Okay, on to the next question. Do you have a metric solution under on-premise or it's only on cloud?
So our metrics is on cloud. It's available on the cloud. But the devices are working in the on-premise. Obviously, devices are offline mode also it works. The IoT platform is on the cloud. The IoT platform also in the cloud. We can it can be there are two ways we are offering it. It's available as a shared environment. So on a software as service model. So it's available in a shared environment. Everybody can subscribe and use it as a cloud application, SaaS application, or we also provide it in a independent cloud, preferably in an independent dedicated instance model as a separation of that from other customers, and that can also be in a private cloud mode. We also support private cloud and delivering it, but we don't prefer to put it in on-premise because the whole idea is to leverage IoT and internet technology, and putting into the on-premise will basically limiting that to accessible only within the premise. So either it should be a private cloud or the cloud that we are offering. We are in Microsoft Azure environment. So globally, we can deploy any corner in the world in the Microsoft Azure. So we can provide a dedicated instance, or we can also do the private cloud instances.
Okay. So on to the next question. For operation managers and engineers, what are the common challenges that they might face when implementing machine productivity monitoring?
So the process is the biggest thing. We bring the system technology, we apply that. So there is a process involved. Sometimes the machine is not giving all the data sets that we need it for cycle time, productivity, downtime reasons, and all. Then we are depending on operators. Obviously, operator has to follow the process. So it takes sometimes based on the operator knowledge and exposure, and the organization enforcement, it takes to train the operator to do that. So to train the operator to follow the process, to help solve this problem, we also provide operator training on the HMI. We educate them on how to use that and when they should do that. We set the protocols for them, and we hand over to the operations team to enforce it in the process. So the process, if they follow the process, the accuracy will be very, very high. Again, it's in the control of operators and the operational team involvement. It's not like just a system, that that does everything without that. So it's a holistic approach. So we should have a process in place, and we should follow the process in place for very, very, very high results.
Okay. On to the next question. Is white branding available?
White branding in the sense, it's not like somebody can take our system and then deploy it and sell it. The branding we provide it to the customers. Suppose if let's take Ford, if they wanted to utilize this technology in Ford, one of the Ford company or Ford sister company, and we put their branding and all. So when you say white labeling, yes, that's what we mean it. We put it in a branding of the Ford access, and so that the operation team see that it's a Ford system rather than seeing it's a Fogwing, even though the Fogwing identification will be there in the application level, but we white label it in the sense for the customers aspect of it.
Okay. Thank you, Hari. I think that's all the questions we have right as of now. I think that's it. So thank you, Hari, again for the deep insights. And I think it's now time to wind up the webinar.
Thank you,
So,
everyone. Sorry.
as previously stated, we will be uploading this recorded session uh, of this webinar in our Factana YouTube channel. So, therefore, you can visit our YouTube channel to watch this and also our previous webinar sessions. And for those also interested in gaining any further insights into IIoT, Industry 4.0 smart factories, we encourage you to explore our blog sections at www.fogwing.io/blogs. And also, additionally, if you are seeking any collaboration opportunities, please do not hesitate to contact us at sales@factana.com. Uh, I think that's it. Thank you once again for participating in the sessions and making it a success. We eagerly anticipate connecting with you in our next webinar. Stay tuned and have a wonderful day. Bye.
Thank you, everyone. Have a nice day. Bye.